So here's the homework. And point it out to me if we actually did this in class. I do not think we did. Did we? Write a program that displays the dimensions of a letter size sheet of paper in millimeters.
Yeah.
We did this?
Yeah, we did that in class.
Alrighty. Well, that'd make it really easy homework. Alrighty. Let's just blow this off and see if we can come up with something better. I wasn't happy with this anyways. Why? Because it wasn't really oriented around writing functions. There's a couple places where we could use functions, like a inch to millimeters function, but nah. Okay. We'll nuke that folder. Thanks. Alrighty. So I think we're pretty much done with the functions chapter. Fruitful functions return things. Functions can accept parameters. Example of one that does all three. Or all three. Both of those things is something like this. Define. Add 3, and we're going to accept x, y, and z, and we're going to return x plus y plus z. So if I gave you a problem like write a function which accepts 3 variables x, y, and z and returns their sum. If I didn't give you a name, you could make up your own name. Maybe I would have been nice enough to give you a name. Write a function called add3, which accepts 3 variables. So when it says accepts, that means you're going to need 3 parameters. When it says returns, we know what return means. Alrighty, onward and upward. Updating variables. A common pattern in assignment statements is one that updates a variable. Now in other languages you have the nice little syntax x++. X++ means add 1 to x, store it back into x. For some reason, the guy who invented Python never felt fit to give us a plus plus and a minus minus operator. But you can do the same thing with x plus equals 1. And that's actually not what this is showing, but you can replace x equals x plus 1 with x plus equals 1. And I'm pretty sure that we've been doing that in class already. If you try to update a variable that doesn't exist yet, that hasn't been defined, hasn't been declared, or already have a value assigned to it, then you'll get an error, of course. So anytime before you can update a variable, you have to initialize it. Usually with a simple assignment, something like that. X is equal to 0, and then you can start adding things to it. Updating a variable by adding 1 to it is called incrementing. Subtracting 1 from it is called decrementing. And so, shortcuts, also known as compound assignments. If you do x is equal to x plus 1, the shortcut for that is x plus equals 1. If you want to do x is equal to x minus 1, x minus equals 1. You even want to multiply it by 2, x is equal to x times 2, you can do x times equals 2. Guess what? You can do divide by, x divide equal to 2. You can even do modulus, x modulus equals 10 if you ever felt the need to take the modulus of it and store it back into x. These are just shortcuts. I won't say it's better, but you're going to see them used all over the place, especially in languages that support the plus plus and the minus minus. You know, see x plus plus in order to add 1 to x. So you may, I would recommend you get used to doing it. We taught from a textbook last semester that spent like 1 sentence describing this thing, and then said, oh, we're not going to do this. And I had used plus equals in all of my examples, you know, from the beginning of the class to the end. And so people were like, what? So, you know, I had to reiterate very carefully. what it did. That was a remote version of the class, not an in-class one. So the while statement. We pretty much know what while does already. We have a condition here. As long as this condition is true, it goes in here and does that code. But unlike an if statement where it executes those two statements and then just immediately exits, it runs back up here, checks that condition again, and if it's still true, it repeats it. So to prevent a while loop from going forever, the condition needs to be something that can change to false, or you have to provide a break statement. Break statement is not mentioned until later, but that's two ways of getting out of a loop. So if you write something that looks like this, while condition, colon, do something, that something had better change the condition so that eventually it becomes false. So if you did this, while x is less than 10, and then you print x, that never changes the value of x, so it'll loop forever. If you are not going to change the condition, you will need to provide a break. That comes in when you just want to write something that you want to loop forever, but then exit on a very specific condition. While true, if x ever hits 100, break. Now that looks kind of pointless, like you could have just written while x not equals 100, but there are times when you want to use a break, or at least the way my mind works. For example, you could ask the user for input, and you could say, or enter -1 to exit, and you could check. That way you wouldn't have to declare the variable beforehand. You can always word these things in more than one way, but something that Python does not have that a lot of other languages do is a do statement. In some languages you can do this. Do, and then you get some input, x is equal to whatever, while x, whatever your condition is, like that. This will always execute the code at least once, as opposed to a while statement, where if you had this, while x is equal to 100, do some stuff. I'm going to put do whatever right there. If this is not true, then it won't ever execute that. But if this is not true, it goes ahead and executes that. Why? Let's say that x is equal to 1 here. X is equal to 1. Do this. Do whatever. While x is equal to 100. Well, if that's not true, it goes ahead and exits the loop. But if x is equal to 100, it would start repeating. So this check happens before the code works. If x is equal to 1, if x is not equal to 1, we don't even get a single iteration of that. In this one, the check happens after the code is executed. So do whatever will happen at least once, no matter the value of x. Python doesn't have that structure. So this kind of thing is, the do structure is pretty good for asking the user what they want to do and then asking them if they want to continue. And then if they want to continue, bail out. Anyways, you will see me use the break syntax a lot for doing things like please enter score, while true, print, please enter score, or -1 to quit. That kind of thing. And then you get your input. Score is equal to input. Even without converting it to an int, we can check what it is. If score is equal to -1, then we break. That gets us out of the while loop. Otherwise, we can do whatever we wanted to do with that score. Or if you're going to, present them with a list of choices, while true, colon, print, do type A for whatever, B for whatever, or Q to quit. Then you get your input. Choice is equal to input. And you can just check right off the bat. If choice is equal to Q, then break. That's not the only way to do this kind of thing, of course. You could set your choice variable equal to some kind of neutral value up here. Here's how you would have to do this. It's not a big chore, but let's reword this one. Without the while true. We would have to create a score variable and set it equal to something that's not going to cause it to bail. While score is not equal to -1. Then we could ask them for the score. Please enter score or -1 to quit. Then get the score. Score is equal to input. Then convert the score. Score is equal to double score. Then you can do your check. If score is not equal to -1, do something with that score. Anything wrong with doing it like that? Nah, not really. Either is totally fine. The last way that you'll see people structure this is they'll ask the question before they even get into it with what's known as a priming read. And then they'll repeat the question down here. And so I'll show you what that looks like as well. But I'm going to copy and paste because I'm tired of... Alrighty. Please enter a score or -1 to quit. Get the input. Double score. Now, if they choose to quit right off the bat, while score is not equal to -1, do some stuff. Then you have to do all three of those things again. Ask them to give you another score, like that. This is what's known as a priming read. You get a piece of data before you go into the loop. You process that piece of data if it's acceptable, and then you ask for the new piece of data. I don't like this one because you do the input twice. I would rather structure it like this, where you ask for it only once, or like this, where you ask for it only once, and you just do a little bit of logic. Rather than, I avoid priming reads if at all possible. So here we go. Here's our example. N is equal to 5. While n is greater than 0, print n, so it's going to print 5. N is equal to n minus 1, so it's going to loop. First n is equal to 5, so it prints 5. We subtract 1 from n, it's 4. We print 4. We subtract 1 from n, it's 3. 3, 2, 1. Now that we've printed 1, n is equal to n minus 1, that becomes 0. N greater than 0? No, not anymore. So it skips, it bails out of the loop, and it prints blast off. So that would print 5, 4, 3, 2, 1, blast off. So when you're talking about loops, one pass through the loop is called an iteration. This code here is written in such a way that it would iterate through the loop 5 times. Sometimes you can't really predict how many iterations there are. If you did it like this, please enter a score -1 to quit. We could keep track of how many iterations we've done. We could set iterations is equal to 0. And then down here we could do iterations plus equals 1. We could keep track of it, but we don't know in advance how many iterations there are.
So on their example that they have in the back, you could change it to n equals whatever input they do, and it'll just count down from whatever number they
Exactly. We could ask them for it, and then it would count down from 100 to 1 or whatever we specified. Right.
Professor?
Yes, sir.
So it doesn't have a x++ function, but it does have the plus equals function?
Right, which is the same.
Okay.
As long as it's plus equals 1. Most languages support both, or at least all the C divergent languages support both plus and plus equals whatever. So infinite loops. An endless source of amusement for programmers, I know that I think about this a lot, is the observation that the directions on shampoo that says lather, rinse, repeat is an infinite loop. There's no iteration variable telling you how many times you should lather, rinse, and repeat. I've always wondered about that, actually. I mean, are they just encouraging you to use the entire bottle?
Yes. Once it's empty, go buy another one.
Yeah,
And
yeah.
do it again.
And,
Perfect marketing.
yep. Does anybody ever lather more than once at a time? I don't. Anyways, so
I think I've only done it.
this is an infinite loop because there's no way out of it. There's no break statement. You know, we could put a break statement in our activity. If hair is clean enough, break. So if you have something that's an infinite loop because the condition never changes, then you can use a break to get out of it. N is equal to 10. Print N, subtract 1 from N. Wait a minute. Print's done. Now there's something wrong with this code. It'll print 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4, because there's no way for it to get out. This condition is true and there's no break statement. So if we were going to fix that, we would want to insert a break in here at whatever point we wanted to stop. If n equals 0, break. Then it would print 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And what does this little business do here? Have we seen that before? That end is equal to thing?
I don't think so.
Yeah, you showed it to us.
Let's do it
Doesn't
again.
make it run or go to the or stay on the same line.
Right, right. Let's do that again. Int, not doing Java. X is 0 while x is less than 10 colon print x comma end is equal to a space. And then x plus equals 1 and then stop indenting. So printed it all on the same line. If you leave off that end equals parameter, it goes to the next line each time. So this end equals something is really useful if you're trying to print a table, you know, or anything that's going to require you to execute more than one print statement at a time to complete your task. Some languages differentiate. They have either a print or a print line. And if you do a print, it doesn't go to the next line. If you do print line, it does. But Python assumes you always want to go to the next line unless you tell it otherwise. Suppose you want to take input from the user until they type 1. You could write this. Let's give it a shot. It's not telling us what we want to do, so I'm just going to type something. Something. It prints out something. Hello. Goodbye. Stop. Finally, I figure out I'm supposed to type done, and it quits. While true, get our input. If our input is equal to the word done, break. Otherwise, it's going to repeat this infinitely, as long as they don't type that, or until the shell is closed. We're going to see a lot of other examples of looping. More of them actually use the syntax for than while. You can also finish an iteration or cause an early repeat of the condition check with the word continue. Now this is a bit silly, but we can demonstrate this. X is equal to 0 while x is less than or equal to 10. Print x, x plus equals 1. We're going to increment x immediately. And then if x is equal to 2, colon, we're going to continue. That means go back up to the top of the loop. Otherwise, we're going to print x. So what is this going to print? It's going to print 1, 3, 4, 5, 6, 7, 8, 9, and 10. Something along those lines. It's going to skip 2. just going to call it skip 2. There we go. 1, 3, 4, 5, 6, 7, 8, 9, 10, 11. Why did it skip 2? Because this checked. And if x was equal to 2, the continue caused it to end that iteration early and go back up to the conditional again. So it never did this. It's kind of like doing this. Kind of like we had a if x not equals 2 around this code all the way to the end. But you may have a lot of circumstances in which you want to continue, more than one in the same loop. However, be warned that it makes your code more difficult to read. You know, breaks are bad enough, but at least with a break you kind of know that there's going to be, you know, probably one specific way out of the loop. With a continue, it sits there kind of hidden in the code, and you don't know why it skipped 2 or whatever. I would advise against using it unless you run into a situation where you really think you need to, in which case just document it. Why are we skipping 2 here? I don't know. What could you use that for? Well, you could ask them for some input, but then if they typed in a 0, rather than process it, you could just continue and force the issue. Keep going. So I'm going to write something like that. While true, colon, x is equal to input, give me a non-zero integer. And then x is equal to int x. If x is equal to 0, they were a bad boy. We're going to print out a scolding message. You fool. I said non-zero. And then we will continue. And then from this point on, we could assume that x is not equal to 0. So it's safe to do divisions and stuff like that. This is a fairly common idea. Eliminate your errors as soon as possible. And this is one way to do it. Another is to write a function which does the input and forces them to type in a non-zero number before it exits the function. But this is a way to simulate that pretty easily. Just a few lines of code. I'm just going to make it print out x when it's done. As long as you enter something that's non-zero. 1, that's great. 0, you fool, I said non-zero. Okay, you get the idea. We stopped it from continuing at that point. I mean, we didn't stop it from continuing. We forced it to reiterate early, to abandon the loop early, to come back up here and to check it again. That's different from a break statement, because a break statement causes it to go to the end of the loop and to stop looping. Continue causes it to go back to the beginning of the loop and to keep repeating, or to check the condition again.
So does continue have it check if x is equal to 2 again, or does it have it check all the way at the top?
Well, if we're running this, the first time it gets here, x is 0. Is it less than 10? It sure is. So it adds 1 to it. It does the check. The check is not true, so it prints x out.
Oh, okay. I see. You have the you don't have the print statement in there. Okay.
And then it comes back up here. X is now equal to 1. Is 1 less than 2? 10? It sure is. So x goes up to 2.
If x equals.
And then if x is equal to 2, it doesn't do anything. So we don't print out 2. We skip back up here. And it checks that condition again.
So how come when you run it, after it gets to 2, it continues to count?
Because it's not a break statement. A break would kick it out of the loop.
Okay.
If we did if x equals 2, then break, then it would stop. Let's put a break in here. If x is equal to 8, we're tired of running, so do a break. So this is going to print 1, 3, 4, 5, 6, 7, but then stop there. The continue causes it to run back up here rather than leave the loop. The break causes it to leave the loop. Does that make sense? Okay.
For the bottom part, would it be a good idea to put a try and accept in case they put like letters in?
Yeah. what I would do if I was writing professional code would be to write an input function which I could use over and over, which did all validation of the input. And then I could just keep using that.
If we do less than or equal to 10, why does it give us up to 11?
Only because I added 1 to x before I printed it out. Let's see the behavior if I move that down to underneath the print x. Well, I'm going to have to get rid of this x statement, this 8 statement. All right, so it printed 1, 3, 4, 5. Wait.
No, it prints 0 and 1.
Yep, click under it.
Oh, there we go. And it's infinite looping now. Why is it infinite looping? Because nothing ever increases x. That's why I had it before there, and that's why. Does that make sense? Okay. If we wanted it to stop at 10, we would just make it less than 10 there, rather than less than or equal to. If that was the behavior that we wanted. So definite loops using for. In general, in programming, if you don't know how many times something is going to iterate, that's when you use a while statement. If you do know how many times it's going to iterate, or at least it's going to be going over a predetermined span of data or set of data, you use a for loop. You can use a while loop in the same case, but a for loop shortens the syntax. I'll give you an example. Where's our code here? I'm going to print out the numbers 1 to 10 again, just because. X is equal to 1, while x is less than or equal to 10, colon, print x, and then x plus equals 1. That took 4 lines of code to accomplish what I am now going to do in 2 lines. While, for x in range, starting at 1, and you'd think that you would put 10 here, but you actually put 11. This is an upper bounds that is not inclusive, it is exclusive. So this would actually count 1 up to 10. And then we could print x. Those 2 loops perform identical functions. But whenever I am teaching programming and I write a for loop that's supposed to increment x, half the time I forget to do the increment, then I run it, it does an infinite loop, I have to break the program and modify it. This leaves no doubt that x is going to be incremented each and every time it goes through it. So we knew in advance the range of values that we wanted to process. That made it an ideal candidate for the for loop.
Like in fundamentals, I remember you doing something like like we would create a list.
Right.
We would say for x and the list. I didn't understand like how that worked.
Yeah, let's do that again. Let's make a list. I'm going to call it names. Names is equal to Joe, Jill, Janet, and Jack. Here's how you would access that list with a while loop. We'd need a counter. Guess I'll call it C. C is equal to 0, or I for index value. And then while C is less than the length of the list, get that variable out. S is equal to names at position C, and then print it out. And then increment our counter, C plus equals 1. That is how you would do it with a while loop. Hope it works. Guess I should run it.
What's S?
We never leave this code, do we? I should have put a break statement in here. Okay.
Yeah, I just had to defend myself.
Things that continue to break.
Yeah. So here's our secret code for getting out. If x equals 1 colon break. There we go.
I just put a break under it.
Pardon me?
I just put a break under it. Just break, period.
Yeah. Yeah, you
So
could
it
do
only
that.
did it once.
So you could only do it once. Yeah, that
Unless
would be
you put
fine.
in the wrong one, then it'll go over.
Then it'll keep repeating. Right. Okay, so give me
9. Well, like 1.
negative 1, 1. That's our secret code for stopping. Okay, so it printed 0 to 10, 0 to 10, and then it printed out the names in our list. Hopefully this part makes sense. Not that we've done a lot of stuff with lists, but those who took fundamentals have seen this. This is an array of names. We're pulling the items out element by element. This one's called index element 0. This one's element 1. This one's element 2. This one's element 3. And so we write a while loop that says while our counter is less than the length of the names list. Well, length of the list is 4. There's 4 items in it. So this is effectively the same as writing while c is less than 4, because we want to access 0, 1, 2, and 3. But if we added names, that would no longer be right. Okay, so that's how you do it with a while loop. A while loop. Now we're going to use a for. For s in names, colon, print s. Does the same thing. It eliminates a couple of lines. We're not keeping track of the counter. The for statement keeps track of the counter. We never even see the c in there. We don't use c to index the list because we don't see it. It's keeping track of that. It's copying the values into the s variable all by its lonesome. And then we don't have to increment the counter. All of that is handled behind the scenes. So these two chunks of code perform identical stuff. It's just that this one's got a cleaner syntax and it hides the details of using an index into the list.
Like, I guess I'm just trying to understand like the logic for like for s in names. Like it just, I guess it's just not clicking.
Right, so it copies each value of the names list into s.
Oh.
The first time s is equal to Joe. The next time s is equal to Jill. The third time s is equal to Janet. The fourth time s is equal to Jack. And then the for loop is done because there's nothing left in there.
And it always goes from left to right.
Correct, correct. Don't ask me how you would get it to behave the other way.
Yeah, I was about to say that sounds pretty complicated.
I bet it's easy, but it's not coming to me. This one would be really easy to modify. You would just start the counter at the end rather than the beginning. And count down, right. So here's their example. Friends is equal to Joseph, Glenn, and Sally. For friend in friends, this is great and all that. I love this syntax of where you use a plural for your list and then you use your singular as your index into it. However, whenever I type code up here and I have variables that are only differentiated by whether they're plural or singular or not, people mess them up.
Yeah, I'd be putting the s where I
Right.
do that now.
Yeah, exactly. So, I mean, I try to avoid doing that, and I don't mind using a single letter variable name. Or if I use something longer than a single letter, then I at least make it very distinct from the list name. Just to,
Like, pal.
yeah, pal. For pal in friends list. For buddy in friends, print buddy. Something like that. So translating this for loop into English is not as direct as while. But if you think of friends as a set, it goes like, run the statements in the body of the for loop once for each friend in the set named friends. I don't know if I'd want to say it like that, but
That's good.
I think I would word it for each friend in the set named friends, print it out. That's how I'd say it. So loop patterns. You will wind up using loops over and over and over. It's really kind of the heart of programming. Why? Because back in the 1940s, when computers were written to try to crack codes in England or to calculate, artillery and bomb trajectories in the United States, you wouldn't want to run a program and have it just calculate one trajectory. You're trying to write a whole book full of trajectories, a giant table of trajectories. Or you're trying to, loop to keep trying to crack the Nazi code or whatever. It needs to go over and over and over. Some of our programs here haven't been looping. That's because we're writing little toy programs for the most part to demonstrate, calculations and things. But instead, you're going to open a file and you're going to read to the end of the file. That's a loop. Or you're going to open a database and you're going to look for all the records that match something and then do something, print those records out or accumulate their sum or, post them to a server or whatever. So it's looping. So loops are generally constructed by initializing some variables before the loop starts, performing some computation on each item in the body of the loop, possibly changing the variables. If you use a for loop, you don't need to change the variables because that's being handled behind the scenes. If you use a while loop, you probably will. And then looking at the resulting variables when the loop completes. So here's an example of that. Here was our setup. We had to declare our names, and then we had to initialize a counter. That was all the setup before we could go into the loop. Here the setup, well, the setup had already been done, but I'm going to copy and paste that names thing. The setup was there, and then we did our processing there. And in this case, there wasn't anything to do. We weren't calculating the sum or anything like that. So there was no post-loop processing. But let's give us an example of when there is. Let's make a list of numbers. Scores is equal to, and let's just type in some numbers separated by commas, whatever numbers you want. Now, to be honest, if you wanted the sum of that, it would be as easy as typing this. Total is equal to sum of scores. Yeah, then if you're calculating average, you could divide by the length. However, we are so awesome that we're going to forget that there's a sum function, and we're going to write our own. So in order to step through this with a while loop, again, we're going to need a counter. C is equal to 0 while C is less than the length of the scores list. But I'm also going to need an accumulator variable, which I forgot to define. So underneath that C is equal to 0, I'm going to put total is equal to 0. Then I'm going to say total plus equals the scores at that specific position. And then I need to increment that counter, C plus equals 1. So that was our setup. This is our processing. And once we've calculated the sum, we may as well print it out. Sum is, or the total is, comma total, like that. Now, we'll do the same thing with a for loop. We're going to need to reset total back down to 0 because we don't want to add the same numbers twice. However, we don't need a counter anymore. So, reinitialize total back down to 0. And then for every, I don't want to do for every score in scores, so I'm just going to do in for number. For n in scores, colon, total plus equals n. And now we can print the total out again. I goofed. I have some garbage up here. I'm going to delete. Where did that go? I guess I deleted my print statement. Print S. Alright, so each time we calculated the same total. Anybody getting syntax errors? I got one, so I wouldn't be surprised if somebody else did. We need the bottom? Okay. Right, just like our names, n equals each number in turn. At first, n is equal to 10, then n is equal to 8, then 34, and then 5, and then 10 again. And then it exits the loop because there's no more data in the list. Yes, sir?
So what does the len function actually do?
It counts the list.
That's
It just iterates through the list. So the length len of scores is 5.
Oh,
Len of names is 4.
I see.
Len returns the length of the list in terms of elements. Length of hello there friend, that would be 3. You can also do a length of a string like this. Length hello there friend. But a string is not a list. I've goofed that. To define a list, you have to put square braces around it, like that. And really, we usually define them above that. So instead, I'm going to take that stuff out and put it in its own sentence. Sin list. So sin list is equal to that, and then the length of that would equal 3. As opposed to this, the length of that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18.
For some reason, mine's not printing it out.
So why did we do this? Just because although the sum function is easily available to us, there may be times when we're summing something that's not already given to us in a list. We just need to have in mind how to process it. And what if it was supposed to multiply all those numbers instead of just summing them together? We would change this right here, but there is no shortcut. There is no sum. There is no, I guess, I don't even know what I'd call that.
How would you
The
get
product function.
How would you get it to make the list where the user put the numbers into the list?
Very good question. And I'm tired of typing stuff at the bottom, so let's come up here and type it at the top. So let's get a list of scores from the user. The pseudocode for this is going to be initialize an empty list. Then, with a loop, add items to the list. That's what we're essentially going to be doing. And then underneath that, we could do something processing the list. Yes, ma'am.
I thought we could do, you were talking about the plus equals, minus equals, whatever. Why can't we do product?
You could do times equals. It would be totally, the reason I was saying we couldn't just call a built-in function is there is no product function where you give it a list of scores and it multiplies all the scores together.
Right.
We could write one like that
Okay.
using times equals, but there's not one built in, unlike the sum function where there is. Okay, so let's declare our list. Scores. It needs to be an empty list, so I'm going to do that. Square brace. Now, while true, I'm going to use a break statement to bail out of this. Print, enter a score, or -1 to quit. Now we need to get that input. N is equal to input. If n is equal to, quote, -1, end quote, break. Why do I do that? I could change -1 to quit to Q to quit, and I would just change it there before I convert it to an int. Okay, they don't want to break, so let's convert it to an int. N is equal to int, int. Now that we have a good number, we want to add it to our list. And then once we're done, I'm going to do print scores down here at the bottom. All right, and list attribute has no attribute add. Is it append? Excuse me. Let's find out.
When you get the error that says int is not iterable, what exactly is
That means that you have a 4x, you have something like this. Don't type this, guys. For I in L, whatever, but L is not a list, it's just an integer. Somewhere up here we have like L is equal to 1 or L is equal to input or something.
Oh, well, because I tried to, what I tried to do is I was trying to set that to like a random integer, so I imported like a random.
Right, you can make a list of random numbers, but you couldn't just make it one number. Okay. So I had .add here, but that was incorrect syntax. That's for a list in another language. You don't have to type this comment, I'm just showing you. By the time you're here, you have a list that you could do, that you could process. It doesn't have to be a numeric list. Whatever you are adding here would be in it. Now Python is a strange language inasmuch as a list does not have to be of identical data types. You could put numbers in there and names and turtles and whatever you wanted to. Most languages they all need to be of the same data type, and they force that upon you. You might be able to get around it with some tricky programming, but in general, that's pretty much what I think is a good idea, is to not be storing different things in the same list. Like if you are trying to keep track of people's names and then their ages, don't make one list called name ages and then try to store both of those things in there. Make two lists, one called names and one called ages, and then just add things to each one. Now I've forgotten who asked how to do this.
I did.
Okay, does that make sense?
Mm-hmm.
Okay,
Most
cool.
definitely.
So that's worth a comment. To enter a list, or to allow the user to enter a list, initialize an empty list, use a loop to add append items to the list. We sure are talking about lists a lot for a chapter that's before us ever mentioning lists. But that's because lists are so important that it's really pointless to talk about while loops without talking about lists. Excuse me, for loops. So counting and summing loops. If I need to go back to that code, let me know. Here's an example of just counting the number of elements in that. You could use the len function. The same idea. For every thing, and they chose this variable name, itervar, for every thing in that list, add one to the counter. And then when it was done, it would give you the length of the list. That's very similar to our summing, except in our summing, what did we add here? We didn't add one to it. If we were going to change this so that counter was equal to the sum of all the items instead of just one for each item, what would I change that to?
You want it to change from sum to what?
I want count to not be a counter, but to actually store the sum of them all. So instead of adding one for every item in the list, I want to add...
Do count equals sum, wait.
Yeah, count is equal to count. I should change the name of the variable. Sum is equal to 0. Sum is equal to sum plus what? Itervar, right.
Itervar, yeah.
Okay.
I was just getting confused because count.
Right. And here we go. Total is equal to 0. Total is equal to total plus itervar.
It keeps going through until it gets to the end and keeps going. Okay.
So let's write some code that will fill a list full of random numbers, and then we'll base some homework on that.
Yeah, I was trying to do that, but it kind of worked. But I was doing it with a while loop instead of a for loop.
So here's what this code is going to do. I'm just sticking it up at the top. We're going to ask the user how many items in the list. Then we will iterate, or we will loop, adding random numbers to the list. I'm just kind of writing out kind of a little roadmap of what we're going to do without doing a whole pseudocode for it. Alrighty. MaxNum is equal to input how many random numbers in list. Now we haven't done import random up at the top like we need to, but we'll go back and fix that. Then we need to convert that to an integer. MaxNum is equal to int maxNum. Now rather than use a for loop, I'm going to use a while. Why? Just because. So I need a counter. C is equal to 0 while C is less than maxNum, colon. Let's get a random number. R is equal to random dot random int between 1 and 10. We need to append that to our list. Unfortunately, we don't have our list defined yet. I think I'll call it nums. Nums.append R to our list, and then C plus equals 1. Alright, now for that to work, I need to change the code in two ways. Firstly, I need to declare nums as an empty list up here before our while loop, and I need to add the statement import random up here. So I'll do that. Import random. I put that before my declarations. It could have gone after, but whatever. Ought to go at the top of the program. And then let's make our list. Nums is equal to, and then square braces to make an empty list. Now let's print our list out. And then let's just put a input, hit enter to continue to stop it from doing all the stuff that follows this part of the program. Alrighty, how many random numbers in the list? 10.
I guess I did mine wrong.
Okay, so I'm going to go ahead and spec out the rest of the assignment here, and then I'll wander around and help people who may not have it working. We want to write code that will print every random number, one per line, calculate the total with a loop and not the sum function, calculate the average, which is total divided by nums dot, or len nums, and print the total and the average. So that'll be the assignment based on those random numbers. Let's make a Dropbox. I know some people like to leave it a little early.
Whenever you have a counter or an index, isn't that in the while loop? Shouldn't that be the last thing that?
It's easier to think about it if you make it the last thing. It doesn't have to be.
Okay.
You just have to make sure you're thinking about it right if it's not. You know, since I've been doing it that way for a semester and a half for you, then you're used to seeing it down there. That's a very, I think it's a good way to do it. But as you saw when I had that increment up at the top of the loop rather than the bottom, and so it was printing out 1 to 11 rather than 0 to 10, that was confusing.
Yeah.
So. Alrighty, whatever we call this code, I guess I'm just going to call it loops. Yeah.
We have so many of them, might as well.
Yeah.
There was no fruit involved in this assignment. No fruit at all.
All right, there's a inbox H, so just upload the script you've been working on, whatever you put in it. And homework 5 will be to add this functionality to the random code, to the random number code.
You said you were gonna come around and look at errors.
Yep.
Refresh this. Put loops in there. Add file. We'll do that. Oh, I'm talking to myself. I'm having a great conversation.